This is TechCrunch.
Decarbonizing our economies in the race to fight climate change demands a wholesale overhauling of all sorts of production processes to make them as sustainable as possible. Greening chemicals, which are used as ingredients in all sorts of products, is where UK startup Deep Blue Biotech is putting its energies. The biotech startup, founded in May 2023, is building a business around a photosynthesis-based form of biomanufacturing that will enable it to manufacture chemicals in a more environmentally friendly way than conventional production methods, such as refining fossil fuels. The startup also claims its method can achieve cost parity with conventional chemical production, since the genetically engineered microorganism it's using to produce the chemicals only requires feeding with relatively cheap ingredients, light, water, and CO2. It says this contrasts favorably with precision fermentation, another microbe-based production method that requires more costly feedstock, such as sugar, too. Deep Blue Biotech is working with a strain of cyanobacteria, also known as blue-green algae, but note, these single-celled microorganisms are actually prokaryotes rather than algae, using genetic engineering and computational modeling to turn bacteria, which is sometimes colloquially known as pond scum, into microscopic production factories for green chemicals. The startup says its method is net positive in terms of carbon emissions, meaning the process removes more CO2 than it produces, since cyanobacteria consume the greenhouse gas during photosynthesis. It also claims its bioengineering approach means it can produce more efficacious chemicals. It wants to improve on earlier industry attempts to formulate more sustainable chemical ingredients, which often led to less effective products, making for a tougher sell to consumers. These are green chemicals that will deliver on both sustainability and performance, is Deep Blue Biotech's pitch. The first generation of green chemicals, unfortunately, they just sucked, co-founder Manuel Rios, a former VP of Sustainable Design at Unilever, tells TechCrunch. They were just more expensive and less efficacious, and we need to counteract that effect that happened in the last 10 years. What we start to see with synthetic biology in general is because of how we create and design the molecules. You can actually go and aim for functionality, which is something that we were not able to do in the past, he also tells us. So we create that new generation of sustainable materials, new generation of green chemicals that are environmentally conscious, but mainly they are superior in functionality. That is what we want to create. The cost of producing the chemicals can be another key selling point, depending on the industry vertical it's targeting per Rios. The startup is using computational modeling to determine which chemicals are cost-effective to target the novel production method at. We have selected chemicals that are north of $2,000 to $3,000 per kilo, which allows us to have healthy margins while still delivering a discount versus the incumbent technology, he suggests. Deep Blue Biotech is starting with a sales pitch aimed at beauty and cosmetics companies. Rio says the textile industry will likely follow, where it would be pitching apparel makers on more environmentally friendly fabric dyes. The first substance it's producing is hyaluronic acid, an ingredient in various skincare products and cosmetic treatments that can also have medical uses. We're not going to save the world with cosmetics, but what we're trying to do with that industry specifically is we believe it has the ability to change perceptions, he says, adding, we believe a partner like the beauty industry with high levels of engagements will allow us to be more effective. Cosmetics also offer a quicker route to market compared to some other applications it could have focused on. Rios notes the team had originally considered producing biofuels, but decided it would take too long to translate from lab to market, and he stresses they are keen to have a positive impact sooner rather than later. While there has been interest in photosynthetic biomanufacturing before now, including for producing biofuels, Rios suggests commercialization has been held back by low production rates. The startup reckons it's made a breakthrough thanks to use of a relatively recently discovered high productivity strain of cyanobacteria. The main advantage that this strain has is it's 3 times faster growing than any other strain of cyanobacteria ever discovered and has 7 times more productivity. So that kind of breaks the barrier in terms of commercialization, he suggests. It's still early days for Deep Blue Biotech, which is announcing an $800,000 pre-seed round to keep building towards its commercial MVP, a small-scale demonstrator of production in this context. The round was led by Sustainable Ventures with participation from One Planet Capital, PCSI, and SFC Capital. It also included 2 Innovate UK grants. The funding will be used to kick off their first paid pilots, entering into joint development agreements with customers to incorporate the Deep Blue Biotech's hyaluronic acid into their own products. Rios notes they have several letters of intent signed with cosmetics firms it hopes will be future customers, including his former employer. Additionally, they will use the capital to find their second ingredient, probably the aforementioned textile dye. Part of the funding will also be spent on filing a patent application, according to Rios, who confirms they intend to take steps to ensure their approach is defensible. Growing the team to expand in-house expertise in bioprocess engineering is also on the cards, he says. We are in the experimental phase because we are doing the scale-up and the genetic engineering in parallel, he tells us. Every vertical we target would have a different commercial strategy, he adds. But at the end of the day, the scale-up of this technology, first of all, the fact that the downstream processing is so simple, it gives a very clear competitive advantage versus any other technology. He also suggests having a modular production process is another key component that can support fast scaling. Photobioreactors are used to create the right environment to cultivate cyanobacteria, unlike the stainless steel vats that are typical of precision fermentation systems. These machines feature transparent tubes to let in light, so the light-sensitive microorganism can feed and grow. Rios says that adding more tubes allows for capacity to easily be scaled up. The way the system is interconnected is in batches, he says, further noting, we are working with partners that have this capacity. In terms of competitors, he name-checks the French biotech Microfit, which has been working with microalgae for many years, and inked a strategic partnership with cosmetics giant L'Oreal back in 2022 as interesting. But he suggests their focus is slightly different. Another company he mentions that is working with cyanobacteria specifically and using the same strain is Australia-based Bondi Bio. One of our advantages is, I know what were the right buttons to push in the industry, Rios adds, on its positioning in the market. So we designed a specific hyaluronic acid that we knew would have very fast traction in the market, a low molecular weight hyaluronic acid with a specific property of high skin penetration.